Hey guys, we're going to review some of your factoring rules and practice a little bit of factoring on this video. This is from pages 72 and 73. Okay. And the first type of factoring, we're just looking at greatest common factors. Really, something that comes up a lot when we factor is that there is something common in all the terms that we can pull out before we even start using any of the factoring rules. So for example, A, x cubed minus 5x squared minus 6x. All of these have an x in them. So we pull out that x squared minus 5x minus 6. And now this piece that's in the parentheses is something that we know how to factor. Okay, remember negative 6, the numbers multiply to negative 6, but they add up to negative 5. So negative 6 and 1. So we bring down our x outside, x minus 6, and we've got x plus 1. Now, if we go ahead and go on to B with this, we can see, hey, this is 3x cubed minus 27x. My GCF again is going to be that x that I can take out. And actually, I can also divide both of these by 3. So let's take out 3 and x. If I divide those out, remember we got to divide, so we're going to have x squared left here minus 9. Now this is a special case rule, right? This follows the pattern a squared minus b squared, the difference of two squares, and we should have a plus b times a minus b. So this is a special rule, one you should be familiar with, right? So a is, in this case, we're going to match up a with x, right? And I'm going to call b as 3 to be 9 squared. So here we go, 3x, x plus 3, and x minus 3 using that factoring rule. Okay, so that was B. Moving along, let's take a look at C. 3x cubed plus 9x squared minus 162. Okay, what can we factor out from all of these? Well, lucky for us, all of these are divisible by 3. So let's take out that 3 from all of these. 3x cubed plus 3x squared minus 54. Now, is this trinomial factorable? Actually, it's not. The pattern's kind of messed up here, right? Cubed squared. So we're actually done at this red line because we don't really have anything else we can do. So all we could have done was divide out that GCF of 3. Now, if we look at D, we've got x to the 4th minus 9x squared plus 14. And if we look at this, you're immediately like, wait, there's no GCF here, okay? What we're going to do is we're going to treat this like it's a quadratic, even though it's not exactly a quadratic. So what I'm going to do is I'm going to pretend this is x squared squared, 9x squared plus 14. And what we're going to do very simply, we'll just call these a different letter. We're going to call them u. So here's u squared minus 9u plus 14. And this is something we can easily factor. All right, we're just going to note over here. What did we do? We said x squared is u. Okay, we just substituted that in there, and that makes it a little bit easier for us to factor. So going back to our old rules, the numbers multiply to 14 but add up to negative 9. So we got negative 7 and negative 2. So right now I've got u minus 7 and u minus 2, sorry. And then all I'm going to do is I'm going to go back and say, hey, wait a minute. These were x squareds. So finally I've got x squared minus 7 and x squared minus 2, neither of which are going to factor. So right here in green is my final answer. Okay, so our next type of factoring is going to be factoring by grouping. And we factor by grouping usually when we've got 4 terms or when we can make it into 4 terms. Factoring by grouping, very useful technique, and it's one that we use a lot to help us break down polynomials. So here's how we do it. Let's look at example E, x cubed plus 6x squared minus 5x minus 30. Now we group, okay? So first two terms and last two terms are grouped. And I'm going to look for GCFs. So the most common factor I can take out from the first one is going to be x squared. And I'm going to be left with x plus 6 after doing that. Now, whatever I remove from this second group, I also should end up with x plus 6. So I see that I can divide both numbers by 5, and I want them to be positive. So let's take out that negative 5, and I'm going to be left with x plus 6. Now note, these need to match. These two parentheses right here have to be matching. If they're not matching, this is not right. Okay, so let's just make a note real quick. Those must match always. Okay, so if those don't match, either you didn't take out your GCFs correctly, or this is something that would not properly factor. Okay, once we've gotten that, we're going to combine these two, my loose pieces, together into their own single factor, and then the two highlighted pieces will become a single factor, right? And this right here is my factored form for E. Okay, let's try out another grouping problem. Let's try F. And so I've got x cubed plus 4x squared plus 2x plus 8. Again, when we group, first two, last two. So here we go, first two and last two. What is my GCF? Think through that for a second. Okay, hopefully you got that it's x squared. We've got x plus 4. Again, I need another x plus 4, so we're going to take out 2. So positive 2 from there, and we've got x plus 4 here. Again, at this point, we can kind of check our work. We know that these are supposed to be matching. And we see that, hey, they're both x plus 4s, so we're good to go. Let's keep moving on. We're going to combine x squared and this plus 2 to make x squared plus 2 a single factor. And then we'll take these guys that we've highlighted as our other factor. And there we go. We've got this one factored out. Okay, last example of grouping, G. Let's take a look at what we've got. X cubed plus x squared plus 2x plus 2. Okay, if you can, go ahead, try to solve this problem, and then check your work against what I have. So I'll start by grouping my first two and my last two together. Let's see what we can take out. From the first one, I can take out an x squared, and I'm left with x plus 1. From the second one, I'm going to take out 2, and we're going to have x plus 1. All right, and now let's combine together. So x squared and 2 will make x squared plus 2 again. And we've got our parentheses, x plus 1s, and we're going to go ahead and group those into a single term. So here is my factored form for G. Okay, talking about the sum and difference of two cubes. So we've seen the squares formula. This is the cubes formula now, okay? And one handy rule that we can use to always remember this formula is SOAP, talking about the signs, okay? So when we talk about the signs, you'll hear me say SOAP, okay? And that stands for the first sign is always the same. The second sign is always the opposite. And the third sign is always positive, okay? So you can remember SOAP, SOAP, and that means same sign, opposite sign, always positive compared to what we have right there, okay? And the numbers are always the same, right? It's all A and B. So we've just got to figure out what is my number being cubed, and we've got it, all right? Now, I'm going to take a second. Let's talk through the first 7 cubes and see what those numbers are. Okay, so in your book it mentions, hey, these are the common cubes. Let's go ahead and fill that section out real quick. And we can say that, hey, 1 cubed is just 1, 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. And 9 cubed is 729. 10 cubed is 1000. Okay, so guys, these numbers are just really helpful for us to kind of be familiar with. Do you have to know all of them off the top of your head? No, but it's very helpful too. Okay, so there's a little section where they noted these numbers down. I would suggest having that written down just so that when we look at cubes, you can very quickly identify, hey, this is this one and that. So 216 is 6 cubed, for example, so you can easily identify that. Okay, let's see how that's going to apply. We'll do the first example pretty quick here. Okay, so if we look at A, we see x cubed plus 8. And I see that as being 8 is 2 cubed. So here we go. This is x cubed plus 2 cubed, which means if you wanted to really think about it, I'm going to set A as being x and B as being 2. And we're just going to fill in our formula. And we're going to use the sum formula here. Okay, so A plus B is going to be x plus 2. A squared, x squared, minus a times b is 2x, plus b squared. So what is b squared? 2 squared is going to be 4. Okay. Again, if you're not sure about that or you missed it, this one is 2 squared. And in case you missed it, guys, this is the formula a plus b, a squared minus ab plus b squared, right? So I plugged in x for a and 2 for b. All right, let's knock out these next couple. Remember to refer to that list of cubes to help you with this, okay? So let's look at b. B is going to be x cubed minus 343. And if we look back at our list, we've got to have a cube here. So 343 is going to be what? 7 cubed, right? So in this case, again, I really like to identify a and b. So I'm going to call a as being x and b as being 7, okay? And this time I'm going to end up using that difference formula. So here we go. We're going to lead with a minus b. So that's just x minus 7. A squared, so x squared, plus ab. So a times b is 6, or x times 7 is 7x, plus b squared is 7 squared, 49. And there you go. There's my factored out form. Again, this 49, if you're missing it, this 49 is actually 7 squared, or b squared. Okay, so don't let that part throw you off. All right, let's try out the next one, right? We're going to try out C, and C is going to be a little bit different. So we've got 8x cubed plus 125, all right? And we're going to again break this down into cubes. So this time we've got numbers on both of them, okay? But that's not really anything too insane. So what is 8 the cube of first? Should be 2. So I'm going to call this 2 cubed with an x cubed. So here we go. We got 2x all cubed, okay? So that's going to be my a value. And 125 is just 5 cubed, okay? So here we go. I'm going to call a as being 2x and b as being 5. And we're again going to use that sum formula, okay? Because these are being added together. So here we go. We've got 2x plus 5. 2x squared, okay, and this time I'm not going to simplify it yet. We'll simplify it at the end. Minus 2x times 5 plus 5 squared. Okay, and I'll go ahead and simplify it now. I just wrote it out that way so we could see how it's all plugged in. And here we go. We got 2x plus 5, okay, 4x squared minus 10x when I put this together, and plus 25. And there we go. This is my factored out form right here in green. Okay, so that was factoring cubes using our sum and difference of cubes formula. Okay, so remember, if you're adding cubes or subtracting cubes, you can use this formula. Look out for things like part C where we had a number and a variable combined together as a cube. All right, so solving using the zero product property. Okay, so zero product property means, remember, each factor you get can give you a single individual zero, and we should always get things equal to zero before we can factor them, right? So number one's great. They already put everything on one side, so that one shouldn't be too bad. Let's see how it looks. X cubed minus 6x squared minus 27x equals 0. And just take a second to think about how you'd approach this and what's the first thing that you would do. I'm hoping that the first thing that popped into your head was to take a GCF, because we have a GCF here of x, so we can take out x and leave ourselves with x squared minus 6x minus 27. And now we can factor this just like any other trinomial. All right, we're going to say what numbers multiply to be negative 27 and add up to be negative 6. I've got negative 9 and positive 3. So I end up with x minus 9 times x plus 3. And don't forget to bring down that x that we had out in front here. Just got to make sure we bring down that GCF with it. Okay, so all of this is equal to 0. If I wanted to actually get my solutions, remember we could say x is 0. This one is going to give me x equals 9, and this one will give me x equals negative 3. So that was if we wanted the solutions. So when you see the word solve, we want solutions, so we're going to find them like this. Okay. Once we have the factors, it's pretty easy to go from there. Let's take a look at number 2. Number 2 is another one that shouldn't be too bad. We've got x cubed equals 25x. And the first thing you should notice is, guys, not everything is on one side. We don't have it all equal to 0. So the first thing we should do is let's subtract that 25x to the other side. And we've got x cubed minus 25x equals 0. And of course, what should we start with? Our GCF. So let's pull out that x squared minus 25 equals 0. And how can we factor this further? Well, this x squared minus 25 is a special rule, right? That's our a squared minus b squared rule. So we're going to use that, and we should end up with x minus 5 and x plus 5. Don't forget our little x out here. We're going to bring that guy down too, equal to 0. And we're going to get 3 solutions from this. We've got that plain old x by itself equal to 0. X minus 5 equals 0, so we get x is 5, and this one giving me x equals negative 5. All right, let's take a look at number 3. We've got 28x minus 5x squared equals 3x cubed. Okay, and again, you notice, wait a minute, not everything is on one side, so we're going to have to do that. One hint I'm going to give you guys. Try to keep this side positive. It'll make your life easier, right? The highest exponent, if it's positive, makes things easier to factor and figure out. So I'm going to subtract my 28x and add my 5x squared. And I'm going to make sure to put these in order. Okay, so here we go, plus 5x squared minus 28x. And here's what I've got now. 3x squared plus 3x cubed plus 5x squared minus 28x equals to 0. And of course, what am I going to go for? That's right, we need to make sure that we take out our GCF, which is x again. 3x squared plus 5x minus 28 equals 0. Okay, and now we're going to look for some factors for this. This can be a little bit tricky, especially because we've got this number in front this time. We haven't seen a ton of that yet. So we're going to multiply the first and last together, and then we're going to use grouping. So negative 28 times 3, and we should get negative 84. I need numbers that multiply to be negative 84, but add up to be 5. And if we stare at it for a minute and maybe use our calculator to help us come up with some factors for this, we should be able to get to 7 and 12, and my 7 is going to be that negative. Okay. And this is where grouping really comes in handy. This is the power of grouping. We take our middle term and we're going to split it. And I'm not going to forget this x. We're going to bring that along with us at the very end. Okay. So we got 3x squared minus 7x, right? That's that minus 7 coming in, plus 12x minus 28. Okay. So that 7x and 12x came from the numbers that we just came up with here. And now we're going to follow this through just like we were grouping. All right. And so let's slide this up a little bit, give us some room. We're going to have group 1 and group 2. Let's factor out as much as we can. So the first thing I see is I can take out an x. I've got 3x minus 7. And from here, 12 and 28 are both divisible by 4. So we've got 3x minus 7. Again, good news, we've got those things matching, right? These parentheses are matching. So we're rocking it right now. As we combine these together, x plus 4, okay, that's these guys, my 3x minus 7s. And of course, let's not forget our little x that we started with, and all of this is going to be 0. Okay, now individually, let's get our solutions real quick, and I'll work them all out this time. We got x equals 0, x plus 4 equals 0, and 3x minus 7 equals 0. Individually set them to 0, and we'll get our solutions. This one's already done. This one's going to give us x is negative 4, and the third one should give us x is 7 over 3. Okay, so that was solving another type of problem by using grouping. All right, now the last one on here reads x to the 4th minus 5x squared minus 6 is equal to 0. And you're going to say, wait a minute, this one's really weird. This isn't even a quadratic, right? How am I supposed to factor this? Do I need grouping? What do I need? Well, we're going to use some substitution to help us make this look like a quadratic so it's something that we can factor. The first thing I notice is, hey, there's a square and this is to the 4th. So this exponent, right, this first exponent is 2 times the middle number, the middle one, right? And that's kind of warning me that this is basically like a quadratic. And I'm going to break up that 4 into x squared squared minus 5x squared 6. And what I can do is I can take these x squareds that I've put in parentheses, and we're just going to pretend like they're a different variable, okay? I'm going to use the letter u, which is very popular in substitution for math, okay? And all of this is still equal to 0, okay? And let's just make a note here. U is actually x squared. Now, this second piece that we've come up with, this u squared minus 5u minus 6, that is very much so something we know how to factor, right? Negative 6, we break it up. We get, hey, negative 6 and 1 is going to come up to that negative 5 that I wanted. And I've got u minus 6 and u plus 1. Okay, and I'm going to write that a little nicer. Now, this is all great, but wait a minute. We know that this is not a problem about u. I started with x's. Let's put back the variable that we started with. We've got x squared minus 6 and x squared plus 1 equal to 0. And we can solve these individually, right? We could try to factor them further, but they don't break down. So let's just solve them individually. I'm going to do them off on the side here. X squared minus 6 equals 0. Add 6 and take the square root of each side. So I've got x is plus or minus root 6. That's kind of important, guys. Make sure that we note that plus or minus, okay? And the other one, We'll do that in a different color. X squared plus 1 equals 0. X squared equals negative 1. Wait a minute, when is a square a negative? Well, even if we forgot that, as soon as I take this square root, we get no solution from this one. So basically, we just get to throw this one out. But this is my solution, plus or minus square root 6. Okay, so that is solving using factoring, right? We're using all these factoring techniques to get us to the zeros for these problems. All right, now the last bit of this is going to be working backwards from zeros that we were given. Okay, so they want us to write this in standard form, which means we're going to multiply everything out at the end. All right, but each of these zeros is going to give me a factor. For example, x equals 2 comes from the factor x minus 2, right? And if you're not sure how we get that, remember, if you get x equals 2 and we wanted that to equal 0, we could get x minus 2 equals 0, right? So this is kind of the long math showing you how we got that factor, okay? Now, the second one is kind of funny, right? We're not going to write this. We don't really want x plus 3 over 4. We don't really like that, okay? What we do is we actually take the bottom of this fraction and we move that out in front of our x. So instead of this, we're going to have 4x plus 3. Now notice some things, guys. These signs are always the opposite of what you see in there, okay? Anything you would divide by, you actually just shift it out in front of the x. You multiply it over. We don't like having a bunch of fractions in here, okay? How am I going to get this into a polynomial? Well, very simply, all we're going to do is we're going to go ahead and FOIL this whole thing out. All right, so we'll take x times 4x first, 4x squared outside plus 3x minus 8x and minus 6. Combine our like terms in the middle, 4x squared minus 5x minus 6. And if we wanted to, we could go ahead and say that that's y, or f of x equals, okay? But there you go. There's my polynomial, all right? And we can do the same thing with that second one over here, right? So if you're feeling confident, go ahead and give it a try yourself. Otherwise, you're welcome to also just follow along. Okay, kind of one of the funny points of this one, x equals 0, right? That's just a plain old x out in front, okay? My x equals 1/2. So my 1/2, we're going to make that into 2x minus 1, okay? Remember, number on top comes out here with the flipped sign. The bottom number comes out in front. And x is negative 1. That one's going to give me x plus 1. Now, the easiest thing I'm going to suggest, start with the binomials and multiply in that green x at the very end, okay? It's just going to save us a little bit of math. So here we go. 2x times x is 2x squared plus 2x minus x minus 1. And not forgetting about our little x out here. Okay. Distribute that x in there, and we've got 2x cubed plus, we're going to combine these together to just be a plain x, times x is x squared and minus x. And there we go. This is my polynomial right here. Okay, we could write it as a function, or we could say it's equal to 0, however we really wanted to. But this is a polynomial with those roots that we mentioned. Okay, all right, hope this video was helpful to you guys, and good luck with all the studying.